We've made it to the end of the road. Or the end of the beginning of the road is probably more like it, at least for me.
End of the beginning of the climb.
Yeah.
Are there only 6 participants?
Looks like so far. It's still a little, just now turned 9.
Okay, great. Great to hear the news that you're starting the European group.
Yeah, I'm really looking forward to this.
Yeah, much needed.
What time is it for you, Mahesh?
Now?
Yeah.
It's 7:30 on Saturday evening.
7:30 on Saturday evening?
Yeah.
Okay. So the meetups are early morning for you?
Yeah, 5:30 in the morning. So, but it's good, because once you get up, you're fresh, and then early morning is the best time to get to grasp concepts. I'm sorry I couldn't join the last one. I was not well, even though it was a holiday over here.
Mm.
The one on, I think, quaternions. It was.
Mm-hmm.
The topic also sounded very complex, so I said, let me give it a rest. I'll catch up the video and the presentation.
It was, but it was good nonetheless.
Yeah. No, I'm sure it must have been because.
It actually looks more complex than it is.
Okay. Okay.
Mm.
Okay.
You should first, if you're watching this video, first make sure that you got your head around the concept of complex numbers and quaternions, and that's really not very, very complicated. At least when you don't tie it to any application like in electric engineering or stuff, then that's more complicated. But when you just look at the concept of complex numbers and quaternions, it's not very complicated. It's just really just made up to have certain.
Yeah.
Yeah.
Actually, I think the leap from complex numbers to quaternions is easier than the leap from real numbers to complex.
Yeah, it is.
Because quaternions have like a physical rotational interpretation. You can interpret in 3D, whereas complex numbers don't.
But the rotation for complex numbers is the same thing. When you have a 2D vector, you can rotate.
But I mean, the complex numbers is the concept is, it's not very tangible. The concept of a complex number, not the rotation.
Yeah. You really have to accept that it's just made up.
No, there's actually interpretations of it. I see complex numbers as a symmetric version of multiplication.
Yeah, it is.
Yeah.
I last remember studying complex numbers almost 40 years ago in my engineering days. Yeah. So I need to catch up on that.
Well, it looks like we've got a small, intimate crew here for our last session, which is fine. I don't know if I'd
send a mail this time.
I didn't send the mail. I was just thinking that. Did I forget to? I thought I had scheduled it in advance, but oh well.
No, it's not out.
No, it didn't get through. It didn't come through.
Interesting how many people are relying on these mails.
Yeah. I wouldn't have thought that to be the case, but maybe so. Well, they'll catch the replay.
Yeah.
And we can jump into a discussion about this last lesson. I guess to get things started off, Mahesh, you were going to talk about Resnet?
Yeah, I'll just quickly take 10 minutes to, just to clarify my understanding of the residual block. So even though I have 50 plus slides, but I think the terminology is quite simple. So I'll go through it quite quickly, excepting for 1 or 2 critical slides where I thought, I'll spend a little more time, but I'll finish in 10 minutes. So I'll try that. So I need to share my screen. So yeah, 1 second, I'll share it. Okay, can you see it?
Yes.
Yes.
Okay, so essentially, as I was saying, I was having difficulty understanding, the presentation which was given on this. I couldn't wrap my head around this particular diagram which was there in the paper. So I dug deep into it, and I started off with, writing down my basic terminology of the of the different layers: the input neurons, the hidden neurons, and the output neurons. The different weights. I have used these notifications where, just interestingly, there are 2 different perspectives. Some people, for example, if I see the weight going from I1 to J1, some people use WI1 J1 as the terminology which I have used. Some people use the other way around. So I thought this is more simpler and intuitive. Similarly, these are the weights which go from I2, the weights which are the biased weights. So the inputs which are coming in at node J1 is essentially, these are the inputs. The inputs which are coming at J2 are these. The output from J1 is essentially the inputs which are coming at J1 plus the activation which is happening, which in this case happens to be the ReLU function. So I have used this terminology where I have said the node inputs are NI, the node NA is the node activation, and NO is the node output. If you remember, I had started doing this in Excel first, but it became horribly complicated. That's why I thought I'll first create this simple terminology and then build it from there. So this is the node J1 terminology. The node J1 again in terms of the activation function. The node J2. So these are the 2 node inputs which are there. The node outputs, which is again essentially the ReLU function, the ReLU activation, which is applied to the inputs which are coming at the respective neurons. So when I see the node now, the yellow is the output which is coming out from the node, and I found this I have indicated the weights again specifically over here because this was something in Excel I kept making a lot of mistakes when I was actually trying to do the calculations by hand. Similarly with the node outputs at J2. And I just wanted to, quickly denote the operations which are happening at the node in matrix form. So essentially I have the weight vector, which is these 4 weights. I have the input vector. I have indicated as I1, I2, and I have the bias vector. So the weight vector, the input vector, and the bias vector. The weight vector is multiplied by the bias vector and gets added to the bias. Weight vector is multiplied by the input vector and then gets added to the bias vector. So if I look at the calculations, I've taken simple examples of weight, the input, and the bias. So essentially, this is the calculation in matrix form. And then coming back to this particular diagram, which is at the heart of the paper. So I could not find any paper or any resource which explained the above terminology on this particular block, with respect to the weights and the biases and the inputs. So essentially, this is the weight vector that I have indicated earlier. This is the input vector X. Now, where is the bias vector? If we see in the paper, they have said that the biases have been omitted for simplifying notations. So B1 and B2 are not shown in the paper, even though that they have, they've done it probably in the Keras or the cafe code. So these are the three essential, the border lines indicated the three levels at which the calculations are taking place. So at the first level, I have the first weight layer, which is W1, X1 and B1. My input vector, X1, my weight vector W1, and B1, the bias. So Fx, which is the first operation, is the ReLU operation involving these three vectors, W into X plus B. My second weight layer is getting W2 as a input, which W2 is actually the weight layer at the second boundary, and X2 is the ReLU of the first layer, first matrix operations. Now Fx, which has been shown over here, is actually Fx2, and this is the formula for Fx2. If I see the input vector which gets added X1, so that gets added over here, which is the element-wise addition. And Fx plus X means this. And finally, when I see the ReLU, it's interesting to note that the ReLU is happening after the Fx and the X are added to each other. So this is how the entire block gets calculated. And important point is that the weight layers should be more than 2, and these can be both fully connected or convolutional layers. So essentially, I wanted to simplify my understanding of the talk which was given earlier, and I thought this would be a good starting point. And then now my next step probably we need to do is look at the code and see how it maps to this terminology with the variables that have been used in the code. My conclusion, simple conclusion, papers would be easier to understand if they were more clearer with the terminology which is depicted against the important images. I came across a good resource on YouTube which has just come in probably last month. I couldn't find it earlier, so it's a good. Let me just try and. It's a 12-minute video which I think is the simplest and the best explanation of the Resnet block. So I'll share this resource on the group later on. So any questions on this? I went through it very quickly because this actually is at the heart of the entire of my understanding, and I would love to get corrected in case I've made any mistakes in this. When we look at the diagram superficially, it looks very simple, but when you actually start writing down the equations, you realize how difficult it is, and you can make mistakes quite easily. So I just thought, yeah. Any questions? Any points?
I'm curious, Mahesh, did you go through the notebook in lesson 7 and kind of how he built up the ResNet from in PyTorch? That seemed to also help with help me kind of put some of the pieces together, although there's still a lot of fuzz there for me.
No, actually, I'll be doing it a little later. Okay. Because what I've realized is that because if you realize the question that I was asking earlier was how come this, because till today I have not yet got an intuition as to why this is working so effectively. Why this addition of x to the at this point is working so intuitively. I've tried to understand it, but I'm still not got I know what's happening, but maybe I don't know why. Yes.
When you're coming from machine learning, then you maybe heard of the concept of boosting. And that's actually, I found very interesting that this is kind of comparable to boosting for other algorithms. I did not see it that way. Jeremy mentioned that in the course video. And
I thought that was really interesting as well.
Yeah, it's with boosting, you try to use weak classifiers and then kind of ensemble this classifiers. And during the training process, you're trying to focus on the error it's making, and that's exactly what you're doing when you add up the residuals. So you're kind of amplifying the error in the model, and the weak classifiers in this case are just the simple Resnet blocks. So each Resnet block, you can see each Resnet block as one simple machine learning model, and then all of these layers are stacked on top of each other. So it's basically a stacked model of simple classifiers trained by, yeah, kind of a boosting method. There is actually a pretty good article from Analytics VT. I will post the link on Slack where boosting is a little bit explained. Boosting is really one of the algorithms that had a lot of attention, I think, in the last years with XGBoost, for example, the tree classifier. That's, yeah, I think, state of the art for tabular data at the moment, for a lot of use cases in tabular data.
Mahesh, if you ever are able to put that residual block or something into a neural network diagram that you say you've never seen, I'd like to see it if you can do it.
Is Mahesh still here? I don't think so, actually.
Let's see.
I guess he just dropped the mic and
run away.
Yeah, I thought that little comparison to boosting was really interesting. I didn't really understand. He kept saying that the residual blocks are predicting the error. And I guess what was confusing about that for me was, are we actually trying to predict the error itself or predict the, predict something that minimizes the error? Are you speaking, Kai? You're on mute.
Yeah, well, I think boosting is trying to focus on the error. So it's when you look at this XGBoost, for example, those three boosted models, then it's kind of, you can understand it as weighing the bad parts, the part that you classified badly more than the other parts, and therefore focusing the classifier on those data points. That's I think basically how boosting works.
Mm-hmm.
So you try to point your classifier into directions of the data space where it's not good at, to learn that. And I mean, it kind of makes sense. So when you have features maybe that are learned very good by the classifier, then you don't want to repeat learning these features. You want to try to focus on stuff that the classifier does not work very well on.
I think we've got Mahesh back.
Also, I don't know if it's really exactly like boosting for tree models, but I think Jeremy meant that it's kind of similar to boosting. I don't know if this is mathematically described exactly the same like boosting.
Mm-hmm. Yeah.
Sorry guys, my Zoom went off, so I'm just connecting via my phone right now. Any questions? Can you hear me?
Yep. Sebastian was saying if you do manage to figure out your ideal neural network diagram, he'd like to see it for one.
Okay. I'll do that. Okay.
Cool. So any other thoughts on this lesson generally? What did folks find interesting? That the boosting and that kind of drilling into the difference, I think, was interesting. Also, I was surprised how relatively straightforward it was to build up this simple ResNet model. Like I would have expected it to be a lot more complex to code.
I think well, jumping away from ResNet, in the chat, someone, Kozaks, asked someone to explain normalization, and I thought it was a little bit confusing, but I think normalization. Someone correct me if I'm wrong. The batch normalization is if when you're working on a batch, say a batch of 3 images, and you're feeding that up forward in your network. Let's say you're at layer 2. You look at, and so in layer 2, you look at all the activations of all the neurons, of all the pixels, filter values from that, and you average that. And so you basically, in one batch, you get 2 numbers out of it, an average activation and a standard deviation for those activations. So from those 3 input images in that batch, you get 2 numbers, and then you use those 2 numbers to normalize all your activations again. Does that sound right to you guys?
I think so, yeah.
Okay.
You do it for one batch.
Right. For one batch, yeah. You get 2 numbers. You basically do all that to get 2 numbers, and then you normalize based on those 2 numbers.
But for each layer, and for each layer, 2 values for each layer.
Right. Correct.
Kazak, was the original question about batch norm or normalization in general?
Is there another kind of normalization?
Yeah, I mean, sure. Normalizing, like in regular and standard machine learning, you'd have all your features and you'd normalize your features just so they'd be on the same general scale.
Yeah. The question is he asking about what is normalization or what is batch normalization?
Right. What is normalization was the question in the chat, and the response to my question was about normalization in general. So the thing that I related it to, or that I think of when I think of normalization, is just standard machine learning. When you've got a bunch of features, you may have the square footage of a house, which is in the thousands, the number of rooms in the house, or bedrooms, which is in single-digit units. And if you are building a model that is using all these different features, the fact that they're not in relative scale with one another will overemphasize, different features, like the features that have the larger scale. And so you normalize those features basically by doing the same thing that we saw in batch norm by dividing out the mean and dividing out the scale and subtracting out the mean. But basically you're trying to compress the feature to this 0 to 1 kind of range.
Yeah.
And batch norm is basically applying that to batches.
Yeah, it happens at, as someone rightly said, it happens at, I think Kai rightly said, it happens after all the activations at every layer. And I think they also do an addition and they do a multiplication of, a constant after the activation.
You're trying to give the model the ability back to kind of shift and scale all the weight values, because it would do it anyway, although you do this kind of batch norm, but you constrain this degrees of freedom by just adding one number and one bias, so one multiplication and one bias for the whole layer, for the activations of the whole layer. In that way, you don't have the problem that the model is trying to do that kind of gradient explosion thing over and over again.
Yes. I mean, essentially, as Sam said, you have to bring down the variations, because what may happen is, supposing after certain rounds of forward propagation and back prop, you may get certain neurons which are having very stronger weights, so these tend to override the other weights. So that's the reason why I think at every layer you will have the normalizationing happening of the activations.
Yeah, I
and
mean,
so now
it's kind of a numerical stabilization of the model.
When you first started talking about batch normie, like the very first step in this notebook was to manually normalize it by these channel norms. And I thought he said something about like how and why the batch norm compares to doing it all at once manually. I think maybe it was this thing you were just talking about, Kai, like allowing the batches to shift around more.
Yeah, I think in the video he said that you don't necessarily have to do this normalization of your data when you're using batch norm, because it's doing it anyway in the first layer when you apply that. But I think he said that he's doing it anyway because in that way you have this kind of two arrays that you can apply at the end and rescale your data, so you exactly know how it's scaled and it's not kind of somewhere in the network and you don't know what's happening. So you can recreate your original data. I think it's just I think a better way to kind of document what you're doing. Because when you want to retrain this, or when you want to use transfer learning with a different model, then you have to provide these values to scale the data. And I don't know. So if it's in the network, will it work? Yeah, I think he said that he used to do it for some time without scaling the data, and just feeding it into the batch norm network. But then he said that it's it's a better way to normalize the data before you put it in the network. But not because it's anyhow better for the model, but just because you know what you're doing to the data.
Context, does that help? Thumbs up. What other any other interesting thoughts or observations from this? My learning rate plots were different than his and kind of weird. Anyone else see anything like this?
No, not me.
I just scrolled through the book. I didn't even shift enter through the book. But I definitely want to code a little bit more in the next time.
Who did that? What is that? I guess Zoom has pencil tools. Didn't know that. Add that to the list of things I learned in this lesson. Yeah, I've never seen anything like this before in a learning rate plot. It's kind of weird. And his on the same data was the one I think that like dropped to a sharp point and went straight up. But I think he also, I don't know, maybe he stopped it here. I think that the scale was different. Any what did you think about this one, Sebastian?
I'm worse than Kai. I didn't even open the notebook. I did it on my phone. Did the video on my phone.
Oh man. Good thing that this is the last one because we've been tailing off, I think, in energy level. Mentioned that last time. So maybe any other thoughts, or we can switch gears to kind of what folks are planning to do next. We've talked about that a little bit last time too. I think for me, it's definitely the kind of digging into that deep learning book. I don't have it in front of me right now. But that was one thing that I want to do. And I do think I'd like to circle back to the Fast.ai course. And, you know, with a little bit more of the foundational stuff, I think give it another look.
Yeah, I actually had a look into this book too. Just I did not start reading it, but I kind of skimmed through it a little bit, and I think that it's really it's the foundations of what you should know when you want to do these things. I think even at one point it says that it's not getting into details in terms of architectures and stuff like this, because it's changing so fast that it does not make sense to put it in such a book. And so it's really the mathematical foundation of what you need to know. And you also can, in the introduction, there is a flow chart, I think, on page 11. It's also, by the way, online available for free. So you don't have to buy the hardcover, where it says which kind of topics depend on each other. And yeah, you can kind of choose. So if you want to just do some image recognition stuff, then you can just find your path through the book.
Yeah, I think if David were on, he'd be reminding us that you can't learn everything, and like the important thing is to figure out what you want to learn and where to invest your time, which is, I think, important. I agree, is important to remember. I think for me, the state that I want to get to is just when we start talking about these different types of networks having a much more solid, like intuitive feel for what's happening underneath. And I think this course kind of gave me a much stronger sense for, you know, in talking about convolutions, for example, what the blocks are. But I still don't really have a very strong sense as to why it works and, you know, why some of the different tweaks that the different models make are more effective.
So I found interesting why are you doing this deep learning stuff? So I can definitely say that I want to have this in my data science toolbox, and more than just using Keras to kind of use some predefined stuff, but I want to know what's going on. And are you guys also want to use that kind of in a professional way, or is it just interest, or?
I'm going to dig into using it towards databases. That's what I'm going to do.
What aspects of databases?
Well, so for example, database at work. I work in mental health, so medical records. I also probably do it with genomic sequence analysis. So there's a lot of data there. And I'll probably go back and redo the course.
Yeah.
Yeah, how will the rest of you be applying this?
As we, when you started off, it's just the start of a climb. And the way I will do it is whatever concepts that I have not yet fully understood in this course, I will dig deeper and, then move on. Because, one of the things which really happened, which was a turning point for me was, the code base has changed. So in the new version, which is starting, he's going to have an entirely new code base. So probably makes sense right now to spend time learning the concepts and then dig into the new code base once it is ready. This is my viewpoint.
think the next part 2 course is starting in January, right?
No, I think October. He's starting it in October, I guess.
But October is the part 1 course?
Yeah, I think it's a new version probably. I don't know. I'll have to check it out.
Okay.
Yeah, I think they're going to do the V1 of the library on the October. That's what they're planning for, right?
Yeah.
And you can at least that's what they just announced, that soon they will open the international fellowships, so you can join the live streaming. Even if you don't live in San Francisco, you can join the live streaming, so you can get the lessons as they at the same time as they do this in San Francisco. So I'm considering to joining them, but yeah, we'll see if I can do that. Yeah.
Okay,
How are you planning to apply this stuff, or what was your motivation originally for doing the class?
Yeah, so I started like a data science, kind of machine learning, deep learning, all those kind of things, and I found out about this course, and I thought it's quite interesting. So this at the moment is kind of like my side project, which I want to turn into a professional career later on. But at the moment, trying to kind of step into that, learn a little bit, apply on Kaggle, and then go from there. Yeah.
Mm-hmm.
Yeah.
And Kojak said that he is doing that on a large acoustic data set. Can you elaborate a little bit on what kind of acoustic data that is? I guess he's not
bioacoustics.
Oh, nice. Ah, okay. So finding out which bird is which one, or?
Bioacoustics.
Huh. Dolphins, whales, manatees. Interesting.
Yeah.
If it's just water, it's just heat, we could do.
Andrew noted that last time when they did the course live in San Fran in October, the videos weren't made public until the end of January.
Yeah. I think he has you can apply for participating, and you can ask questions online.
Mm-hmm.
I think in the videos, there was this person, Jeanette, who read these questions from online.
Mm.
Yes.
I didn't get that. I just thought it was one person that had a lot of questions.
No, I think she's a professor at this university where it takes place.
Okay.
Cool. So in terms of, let's see, were any thoughts or feedback on the study group in general? Was this helpful for folks?
Yeah, for me, it was really useful. I mean, so my background, I'm a full stack developer. I never did any data science or machine learning so far. So I started doing Andrew Young's course, and I heard the podcast, and I came to know about the study group. And that was the sort of push that pushed me into doing the course. So yeah, so for me, it's there's a lot of things that I now understand, which I just had a peripheral glimpse of that. Okay, this is how CNNs are, or this is how RNNs are. So yeah, for me, it's more of I guess there is that machine learning course. Next, I'm planning on doing that, the Fast.ai one. And yeah, and basically trying to get some projects done. I mean, probably try it out on some Kaggle competitions, whatever I've learned in this course. And there are a couple of ideas that I have. I may try it. So there are some clients. I have a lot of tabular data. Probably try, some forecasting and all, which he did. So for me, it's the study group was actually the thing that sort of forced me to work through the entire course. So thanks for that.
Awesome.
Let me echo that, Sam. I've probably signed up for about 10 online courses so far. And this is like the only one that I've ever kind of quote unquote finished. And that's due to the study group.
Yeah,
I
so
don't.
for me, a lot of free courses. It's crazy. It's crazy.
Yeah.
Good. And any thoughts on the format? I saw like Andrew's slides. He did a lot more structure. I knew I didn't have time to do anything like that. But did you like the kind of discussion orientation? Would you have wanted more structure? Any thoughts on, should we do something like this in the future? How you might want to do it?
Yeah, I think we maybe kind of diverted the discussion went in different directions at some point, but I think that's the nature of having a bunch of people and talking about the stuff. Mm-hmm. If you ever attended in any meeting, that's always the same thing. But I found it also great to have it like that. It's really one of the most important things is really just pushing you to really do that. You can't. It's every Saturday, and you can't say, okay, I'm doing it tomorrow. I'm doing it tomorrow. So that's one of the most important things.
No, I think the trick is to find a balance between your, because the learning from this course is very valuable because this course is so advanced. You will always learn new techniques, but it will take time for you to apply them downstream. So I would have, probably the next time we do it, we will need more time, to pace out the sessions, and there should be some structure, in terms of trying to get the basics, understood first, which actually is not something which can be easily handled because people have different, learning paths and learning speeds. But I think it's a very useful course in that sense.
Mm-hmm.
Yeah, I wouldn't want to miss it. It was really good. I learned a lot, definitely.
Awesome. Yeah, it looks like there are a couple of folks who are just joining or getting started. And actually, we had, when I first announced this on the podcast, there have been maybe 40, 30 to 50 people who have kind of joined the sessions over time, probably 20-something regular folks. But there were, I think, close to 1,000 people who said, hey, I want to do this course. So I think there are clearly a lot more people who, maybe the timing didn't work out for the study group sessions, or the timing of the year didn't work out. But if anyone's interested in leading a group like this, kind of going through the course again, like if you think that you want to go through the course again and want to find a way to force yourself to go through the course again by kind of curating these sessions, that would be, I think, really helpful for the people who didn't get a chance to go through it this time. And, I can certainly help provide, my notes from doing this. I tried to keep it pretty simple because I knew I didn't have a lot of time, and can certainly lend the infrastructure, the Zoom and that kind of thing. So if there are any takers on that, ping me via Slack.
Okay.
Awesome.
Yeah.
I thought about going through the book together, but I didn't really had a good idea on how to do that. I don't know if that's a good idea.
Yeah, I was thinking about maybe one thing I was thinking about the other day was whether this Fast.ai channel in Slack, should I just change that to a courses channel or MOOC channel or something that's broader, and just allow people to kind of ask questions about whatever course they're working on, or should that just be general, right? Should I archive this and just move all of that conversation to general or meetup or something? So if anyone has any ideas on kind of the best way to do that, I think it's probably too much to have a separate channel for each course.
Yeah. I think a courses or learning channel would be good.
Mm-hmm.
But one channel is enough, I think.
Yeah.
Maybe we should have a course called Fast.ai course for dummies, because it's, I think that also surprised me, Sam, since, there are almost 1,000 people in the Slack and only 20 people have been regularly participating. I think the course is difficult. It's not something that, we should ignore. It's not something that, it's not easy for people to pick up. So for the rest of the 900 plus people who didn't participate, I think they need a simpler, easier path to, get into it, because, look around you, everybody's, scared of, everybody's scared of AI impacting their jobs and their work. So people are interested, but they need an easier path to, easier way to get into it. This is my viewpoint.
Yeah. Yeah, we've talked quite a bit about the course structure, and I think if I had all the time in the world, probably pretty high on my list of projects would be to, maybe come up with another version of Fast.ai that, does some things differently. Like, for one, the library would have to use decently named variables. And maybe a little bit of a different balance between kind of bottoms up and top down. But I think that would be a much bigger effort. If anyone wants to join in on that, I could be convinced. But it's certainly not something that I could take on my own right now.
No, I think what Jeremy is doing is, in the new version, he has said that, every notebook that is being developed will be aimed at solving a specific set of problems. So, and as we speak, this is work in progress, because he's been tweeting about it for last couple of weeks. So I think they have realized it and they're trying to improve upon it. So maybe the next version will be easier for people to understand. And, as David said, you need to look at the problems that you, want to solve in your day-to-day lives and learn those lessons. Mm-hmm. Otherwise, it's a vast ocean. I mean, there are people who spend decades, let's say, only in NLP or only in vision. So very difficult to focus.
Yeah. Also in the Slack, Andrew put out a call for folks who wanted to join together to work on different competitions like Kaggle and things like that. That was also one of my kind of motivations for going through this course, and particularly with Jeremy's background. I'm not sure when I'll have the time to jump into really digging into competition, but it's definitely something that I'd like to do. But if that's something that anyone on the course wants to do as a next step, I copied it into the Fast.ai channel in Slack and just kind of tag on to that thread. I think that could be an interesting thing to see coming out of this, is a group of folks working on these competitions together. It could be fun.
Yeah. I can really recommend that. I did that when I started doing data science stuff, not starting coding, but starting data science stuff. And it really, at least for me, it really was for learning how to apply things. It was really awesome. So for example, there was this really big data set, and you kind of have to learn how to work with this when it does not fit into your memory and stuff like that. That's something you don't learn in any course or something. That's really, I mean, you won't learn how to apply data science in production for when you do Kaggle, because there are a lot of really specific things, how you train or how you do the modeling and stuff. That's not how you would do it in the real world, but it's for kind of training how to work with data and stuff. That's really good.
Mm-hmm.
Okay. As regards the deep learning book, Kai, someone last time had posted links to YouTube study sessions, which are already there.
I found two. I found two walkthroughs through the book. One is by some university, I don't know which one, and They had, for example, for the introduction, Ian Goodfellow himself talking about it.
Yes.
But some of the videos have very poor quality.
Yes.
In
Yes.
terms of audio, that's not that good. And also I found one study group. They had kind of bi-weekly online meetings, and on each meeting, one of the members presented one of the chapters, and then they talked a little bit about that.
Is that, are the videos that you're referring to that were low quality, the ones that are mentioned on the book site here?
I just posted a link to, yeah, the same one.
Yeah, okay.
I just posted the link in the chat.
Okay. All right, cool. Any other thoughts before we close out a little early for the day?
Last thing I was thinking of doing the machine learning part of the course. And we thought, like, I don't know if it was like in between part 1 and part 2, or it was like during part 1. I don't know if you're aware of the Fast.ai machine learning course they did. Actually,
yeah, there is. We've talked about the machine learning course a couple of times in passing. That's a good question. Is anyone planning to roll into that course after this one?
Yeah, I'm planning to go through that course. So yeah, I'll be happy if people are willing to work through that course. I just had a quick view. It was mainly decision trees and XGBoost. The first couple of chapters were the same things. So yeah, probably next week or in a couple of weeks, I might be starting that course.
Okay. It sounds like Kajaks also is planning to do that. Kyler is asking, I'm not following, maybe that's a different conversation. We all did. So this study group, Kyler, has gone through all of the lessons of the first part of the deep learning for coders. So lessons 1 through 7. The first 3, I think we did at a weekly pace, and then the last 4 we did at a bi-weekly pace.
Great.
Yeah, we'll see if we can. It seems like some folks want to do this machine learning course. We'll see if we can find someone to run a study group for it, if that would be helpful. And if anyone wants to volunteer, again, hit me up on Slack or yell now.
Hey Sam, I might be guiding this another session of course 1.
Oh yeah.
Yeah.
Awesome.
I think I need to do it again.
Cool. All right. Well, let's get together on via DM and figure out timing and all that kind of stuff.
Okay.
And I just found the group of people going through the deep learning book on YouTube. I'll post the link on Slack.
Okay.
Awesome.
Okay.
And was someone saying they were interested in doing the machine learning course?
yes.
Yeah. I was planning on going. Someone else was also there who was saying that they might be interested.
Yes. I'll be doing the machine learning course after this one.
Are either of you interested in organizing a study group?
Yeah, I mean, if people are interested in it,
Yes.
I'll probably ask on the Slack channel. If people are interested, then we can have a study group.
All right, cool. I'll ping me as well on Slack, and I'll try to figure out what the right infrastructure or structure for having multiple of these groups running concurrently. Right now, everyone who is signed up for the meetup gets all of the emails about the study group, and if we expand out to a bunch of different study groups and a bunch of different meetups and stuff like that, that's not going to scale very well. But we can figure out how to make it easy.
I was just thinking, because we talk about theory a lot and kind of, and I'm on the same side, like try to dig more into theory. But I was just thinking, what would happen if we follow the Jeremy's advice and don't worry about theory that much, but just code more, spend more time with code than with books. Because he says all the time that kind of advice. I didn't do that, of course, and I'm just thinking, what would happen if I did that, and if I was like coding more than worrying about the theory. Maybe something worth trying. I'm not sure, but he said he mentions a couple of times that this is the advice he gives for students, and also this is the kind of feedback he gets after the course, that people say like they don't spend enough time with code. I don't know.
I will. I'll disagree with that, because I think when I see people getting only into code, many times they just get carried away by the syntax and they don't really understand the concepts. So understanding the concepts is as important as understanding the code, and especially when the code base is changing. This is my viewpoint.
I really think that this is it's depending on what you want to achieve and what kind of learning type you are. And I did it the same way when I started data science stuff. I first took some online courses, and then I really dig into statistical learning, introduction to statistical learning, and then elements of statistical learning. So it really depends on how you personally, it works out best for you personally.
Yeah. Because also going through the code, you're going to understand quite a lot, because often it's not going to work the first time. So you're going to try to understand why it doesn't work, why a certain library calls different library and stuff like that. So, different ways to get to the same point. But I was just thinking.
If you just want to create a little image classifier for some project, you certainly don't have to dig into the deep learning book. I think so. I mean, the APIs are getting better and better, and at least that's how technology works. You're never ever going to dig into any library you use when you code.
Yep, sure. Yes, regarding.
Sorry, carry on.
Also, other comments regarding statistics for like the participation. So we did local study group here in Cleveland, Ohio, and we had about the same statistics, although the group was much smaller. But we started the course with like 30 people signed up for the course. The first meetup was like 15 guys, and the last lesson was 3 of us. So so I think the statistics are the same, just on smaller scale. Yeah.
Well, I think the last one folks may have been counting on that email a bit more than I anticipated. I sent it out and we did get up to 20 on this last one. So I apologize for those who I made late, but we're here.
A/B testing like in the textbook.
Yeah. Exactly. Well, thank you all for participating in the study group. I got a ton out of it, both in terms of, the motivation to keep going through this, which I certainly would have dropped out a long time ago. So, having you all on board to kind of help keep me motivated was fantastic. The presentations, like Kai, I think you introducing this idea of doing these mini presentations kind of midway was super helpful, and I learned a lot from that. And then just kind of the community of folks, just seeing you all every week, kind of continuing to learn has been, motivating and inspiring for me. So thanks everyone for participating.
Thank you.
Thank you, Sam.
We'll stay in touch in the Slack channel.
Yes.
Yeah, absolutely.
Okay.
Yeah, thanks, guys. Thank you.
All right. Have a great day. Great weekend, everyone.
Bye.
Okay, guys. Thanks.
Bye-bye.